Somewhere in a laboratory in Spain, a researcher is holding a frozen slab of whale muscle under a fluorescent scanner. The tissue belonged to a 70-ton fin whale killed off the coast of Iceland, and the scanner is lighting up. Not from bacteria, not from parasites, from plastic. Synthetic particles embedded so deep inside the muscle fibers that no amount of washing, no amount of dissection could have put them there by accident. But the muscle was not the worst part. That came later, when the same team opened tissue from an animal that had never eaten anything, never taken a single breath, and never once touched the ocean. They opened tissue from an unborn calf still inside its mother's womb. Before we get to what they found in that fetal tissue, you need to understand the numbers behind how this contamination enters a fin whale in the first place, because those numbers are the reason everything that follows should genuinely unsettle you. A team led by Garcia Garin analyzed the stomach contents of 25 fin whales caught off western Iceland. The stomachs were full of northern krill, exactly what a baleen whale that size is supposed to eat. But when the researchers measured the synthetic particle load riding inside those krill bodies, the estimate came back between 38,600 and 77,300 plastic particles entering a single whale every day. Per day, not per year, not over a migration season. Every single day, this animal opens its mouth and filters the water column through its baleen plates. Tens of thousands of fragments of polyester, polyethylene, and polypropylene ride in with the food. Think about what that means for an animal that feeds like this. A fin whale does not pick through its food, it lunge filters. It opens a mouth the size of a small room, accelerates into a dense patch of krill, and engulfs an enormous volume of seawater in a single explosive pass. The water gets pushed out through the baleen plates. The krill stays inside, and with the krill, the plastic stays inside too. Every single pass, every single day, for an animal that can live 80 to 90 years. Now, the obvious assumption is that the plastic passes through. Whale eats krill, plastic enters the gut, the digestive system pushes it out, and the animal moves on. That is what most people would expect. That is what the field assumed for years. The 2026 studies proved the assumption was wrong. Two independent research teams published results within months of each other, both working with tissue from North Atlantic fin whales caught commercially off southwestern Iceland. The first team, led by Ruiz Sagales, examined 13 whales, 1 male, 12 females, all caught during the summers of 2022 and 2023. The second team, led by Vitale, examined 8 whales from the same waters. 2 different labs, 2 completely different detection methods, and when their results came back, they told the same story. The plastic had not stayed in the gut. Ruiz Sagales found micro and nanoplastics in every organ they tested, across every single whale in the sample: kidney, liver, lung, skeletal muscle. 13 out of 13 animals positive across the board. The highest concentrations showed up in 2 places nobody in the field was expecting: the lungs and the skeletal muscle. Not the stomach, not the intestines, tissue that has nothing to do with digestion. The particles had crossed internal biological barriers that took evolution tens of millions of years to build, and they had done it quietly, without triggering any immune response the researchers could detect. Whatever alarms the whale's body is supposed to sound, when foreign material shows up in places it does not belong, the plastic did not trip them. And the way the researchers handled those samples tells you exactly how seriously they treated the risk of someone claiming the lab put the plastic there. Tissue was cut from each whale and immediately placed into glass containers lined with aluminium foil. Not plastic bags, not standard lab containers. Glass and foil, specifically because anything made of polymer could leach particles into the sample and destroy the results before analysis even started. The samples were frozen at -20 degrees Celsius and kept frozen during the entire journey from the Icelandic coast to the laboratory. Subsampling happened under sterile laminar flow conditions, the same clean room protocols used in pharmaceutical manufacturing. Even the tubes used for final analysis had been independently tested to confirm near-zero polymer leaching. Every step of that chain existed, so that when the results came back positive, nobody could argue contamination from the lab. And the results came back positive across the board. But the Ruiz-Sagales data contains something else buried in the numbers, something that, depending on which way you read it, is either reassuring or deeply alarming. Particle concentrations in lung and skeletal muscle declined with age. Older whales carried less plastic in those tissues than younger ones. The liver and kidney showed no such pattern. There are two possible explanations, and the study did not choose between them. Older whales might be better at clearing particles over time, some biological mechanism gradually breaking down or flushing out the material. That is the reassuring reading. The other reading is that younger whales are accumulating plastic faster because today's ocean carries more of it than the ocean their grandparents swam in. If that second explanation is correct, then the contamination levels measured in the youngest whales in this study are not the peak, they are the baseline, and every generation of fin whales born after them will start higher. Now here is where this research crosses into territory that the field has never documented before. 5 of the 12 females were pregnant. The researchers collected tissue from fetal liver and fetal skeletal muscle. Both tested positive for micro and nanoplastics. The concentrations were lower than in the mothers, which tells you the placenta was doing its job. The barrier was filtering, it was reducing the load, but it was not blocking everything. Particles small enough to pass through the placental wall did pass through. The authors described this as the first evidence of systemic distribution and transplacental transfer of micro and nanoplastics in a baleen whale. First, not a confirmation of something the field expected to find eventually. This was the first documented proof that plastic was crossing from a whale mother into her unborn offspring through the blood supply before that offspring ever had independent contact with the outside world. No breathing, no feeding, no filtering seawater through baleen plates, no lunge feeding through contaminated krill patches. The calf's only connection to the ocean was its mother's circulatory system. The blood flowing through the umbilical cord was supposed to carry oxygen and nutrients. It carried plastic too. And the calf had no say in it, no chance to avoid it, no biological mechanism to reject it. By the time a fin whale calf is born and takes its first breath in the North Atlantic, plastic is already embedded in its organs. It enters life pre-contaminated. The Vitali study added a detail that made the picture even more uncomfortable. Their team examined 40 tissue samples across 5 types: blubber, muscle, liver, lung, and kidney, and found that blubber had the highest microplastic abundance and the longest average particle length of any tissue tested. 75% of the particles they recovered were blue fragments. The most common polymers were polyester, polyethylene, and polypropylene, exactly the industrial and consumer plastics you would expect to find breaking down in ocean water. Blubber is not just fat, it is the energy reserve that keeps a fin whale alive between feeding seasons. It is the insulation layer that maintains body temperature in frigid subarctic water. It is the tissue that a nursing mother metabolizes to produce milk for her calf. If plastic is accumulating preferentially in blubber, it is sitting inside the tissue this animal depends on to survive the winter, nurse the next generation, and regulate every metabolic function that keeps a 70-ton body operating in cold water. That is not a curiosity buried in a data table. That is a finding with real biological weight, and its implications for calf nutrition through contaminated milk are something the field has barely begun to examine. If you have been watching this far and this research is new to you, consider subscribing. I cover deep ocean science and the discoveries most channels are afraid to touch every week. Now, there is a part of this story that every summary of these studies leaves out, and it is the part that makes the whole thing genuinely difficult to talk about. These whales were not rescued animals that died in rehabilitation. They were not stranded carcasses found decomposing on a beach. They were killed, commercially, by Icelandic whaling vessels operating inside Iceland's exclusive economic zone. Iceland rejoined the International Whaling Commission in 2002, but it did so with a formal reservation to the commercial whaling moratorium that has been in force since the 1985 to 1986 season. The practice is politically controversial and opposed by multiple IWC member nations around the world. The researchers did not conduct the hunts. They obtained tissue from animals that had already been taken commercially. But the science only exists because the commercial kills happened. Clean tissue collection requires samples handled immediately after death, stored in contamination-proof containers, and frozen without delay. Stranded whales decompose too quickly. Natural deaths in the open ocean are almost never recovered in time. The only reliable source of fresh, uncontaminated whale tissue right now is the commercial hunt. So the most important whale tissue research published in 2026 depends entirely on an industry that most of the scientific community publicly opposes. That is not hypocrisy. It is a genuine structural problem with no clean answer. And that creates a tension that nobody involved in this research is comfortable with. Environmental groups want these studies to prove that plastic is harming the whales, because proven harm builds the legal case to ban the products causing the contamination. The whaling industry wants the studies to prove the whales are fine, because healthy whales weaken the argument against the hunt. And the researchers are stuck saying neither, because 13 animals across a species that lives close to a century is not enough to prove long-term health effects, and funding that kind of decades-long monitoring program has not materialized. Here is what the science actually proved, separated from what it did not. The studies proved plastic is present inside every organ the researchers tested. They proved it crosses the placenta into unborn calves. They proved that the particles reaching fetal tissue include nanoscale fragments small enough to bypass barriers that evolution built to keep foreign material out. They proved that contamination is systemic, not localized to the digestive tract. They did not prove that the plastic caused disease. They did not prove organ damage. They did not prove that any whale in the sample was sick because of the particles inside it. They did not link any cause of death in any of the 13 animals to plastic exposure. Body size and reproductive state showed no detectable effect on contamination levels within the limited sample. The plastic was there, it was everywhere, and the science cannot yet tell you what it is doing. The gap between documented presence and unproven harm is where this research actually sits. And that gap is exactly why the title of this video frames what the scientists found as worse than predators. Not because the plastic is more lethal than a killer whale attack. Killer whales hunt fin whale calves in open water, and that is well documented, violent, and fast. The whale knows it is under attack. What makes plastic different is that it operates on a completely different axis. A killer whale pack has to find a calf, run it down across open water, and physically overpower an animal that is fighting back with everything it has. That is a violent, visible, survivable threat. A fin whale can outgrow it. Adults past 24 meters and close to 70 tons are nearly untouchable by any living predator. The species spent tens of millions of years of evolution reaching that size, specifically because size is the ultimate defense. By every measure of natural selection, they solved the predator problem. But no predator on Earth can place foreign material inside a whale's lungs and liver and kidneys and skeletal muscle simultaneously. No predator can do it without the whale registering that anything has happened. And no predator can reach an unborn calf through the placenta and contaminate its organs before that calf has drawn a single breath. The plastic is not hunting these animals. It is not chasing them. It is riding inside the food they were built by evolution to eat, crossing barriers that were built by evolution to keep threats out, and reaching offspring that were supposed to be protected by the most intimate biological shield a mammal has. And the whale has no behavioral adaptation for it, no way to taste it, detect it, or filter it out of the krill it needs to survive. The contamination is invisible, constant, and it started before the youngest whales in the study were born. Whatever those particles are doing inside those organs, inside that fetal tissue, over the course of an 80-year lifespan, is a question the science cannot answer yet. The monitoring would take decades. The funding does not exist. And the next round of tissue samples that could begin to answer it will almost certainly come from the same source these did. Whales killed commercially in Icelandic waters because no other source provides tissue clean enough to study. Fin whales are the second largest animal that has ever lived on this planet. They are listed as vulnerable by the IUCN, not because of what hunts them in the water, but because of what we did to their populations with industrial-scale whaling across the 20th century. They survived that. Their numbers are recovering. They are still here. But the thing about industrial whaling is that the whales could see it coming. They could hear it. They could try to run. The contamination documented in these studies offers no such warning. It is silent, invisible, cumulative, and it starts before birth. The deep ocean is patient, but the plastic already inside the next generation of fin whales is not waiting for anyone to figure out what it does.